Alright, so just to recap, we said that we will be dividing our problem into two subproblems. The first one being determining what do we need to delete, and the second one is to performing the deletion. And then we said we're going to be optimizing each one of these steps, and then effectively we will be optimizing the entire algorithm, or the overall algorithm, which consists of these two steps. So in talking about deleting characters, we said that there are multiple ways of doing it. We talked about one obvious approach, which involved shifting characters leftwards, but we said that it was a big O of n squared. That was kind of a turnoff. So we moved on to using a string buffer, and that was a big O of n, but then there was this overhead that was introduced, especially the memory overhead. So we had to allocate new memory for the string buffer, and that was a turnoff as well. So we moved on to the hybrid approach, and the hybrid approach basically solves a problem. We will be using one array, so we won't need an extra memory or a string buffer. So we'll stick to our array string, and it will contain, so the string which was to be filtered will effectively contain the output in the end. So, and the way we're going to do it is we will replace characters that need to be deleted by characters that do not need to be deleted. And the way we're going to do that is we're going to use a source and a destination pointers. So, and we'll see how to implement that in code. It's not going to be exactly pointers like in C. We're just going to use integers to actually keep track of where we are looking at. But this is essentially what we're doing, and I'm going to describe the algorithm right here. So we have source and destination, and they both point at the first cell, the first character in the string. And this is how the algorithm works. So we're going to perform something similar to this, shifting characters. But essentially what we're doing is we just want to keep the ones that are not to be deleted. So it's also this approach right here. Remember we were saving the ones that did not need to be deleted into the string buffer? But in this case what we're going to do is we're going to save them but within the same array. So we're not going to incur this extra memory overhead. And this is how we're going to do it. We're going to examine every character, and if that character needs to be deleted, and this is going to be determined in the next step, and we're going to see how we're going to determine that. But suppose we know that this character needs to be deleted. So what we're going to do is we're just going to increment source. So this one needs to be deleted, we're just going to increment source. Source, what it effectively is going to do is it's going to sweep over your entire string, trying to determine the characters that need to be deleted. And so this is the step that needs to be done. If you determine that some character needs to be deleted, character that is pointed at by source, then all you have to do is just increment source. If you determine that a character does not need to be deleted, so suppose this character was determined not to be deleted, so it's not to be filtered, then what we have to do is replace destination by source. So destination is pointing at a character that needs to be deleted. So what we're going to do is we will take that character here, which doesn't need to be deleted, and we will use it to replace the one that needs to be deleted. So it's effectively shifting leftwards, but instead of doing that inefficiently and shifting everything leftwards, we're only shifting whatever we have to shift. So we shift minimally, essentially, and this will keep our algorithm big O of n. So we will take that character and make it replace this one, and then what we do is we increment both this time. So we increment source. Source is always going to be incremented after every single step, and delete will also be incremented and will point at this point. Why do we, destination will be pointing at this one. Why is destination pointing at this character right now? Because this character is just a replicate of this one. This one is the one that we want to keep, since it replaced the one that we deleted. And this one is just a replicate of it. This is the new character to be deleted. And source, suppose it determines this one, it's a character to keep, you don't need to delete it. So what you need to do, you follow this step, you take it, you make it replace that one right here. This one is the one to be deleted, since it's a replicate of that one right here. And you move source and destination, and so on and so forth. And in the end, your string will be determined by the beginning, from the beginning, to where destination points at. And we will see that in the code. So this is a big O of n, and we're not incurring a string buffer overhead, and we're still keeping it to one array. So this is the optimal hybrid approach that we're going to be implementing. Now the first step is, of course, determining what to delete. And to determine what to delete, essentially what we're going to be doing is examining every single character in the string, and this is the filter. And source will be pointing at every single character, and what it's going to do is just going to search for that character within filter. If it finds it, then this means that it has to delete it.